All right, now we get to conditional and absolute convergence, and I'm going to go ahead and try to describe what's really going on here, again, in a fuller context, now that we understand alternating series a little bit better. And let's use the top examples here. Does this converge? No. 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 Name that. I hope you just named it. It's harmonic. I think that's worth writing one more time. This is harmonic. Harmonic diverges. Good to know. Does this converge? Okay, well now it's alternating. Well, because it's alternating, I'm going to use the alternating series test, which is, let's grab some old notes. The alternating series test is two different tests I have to do to determine the convergence of an alternating series. So, switching colors, I'm going to do two things. I'm going to consider the nth term test, and I'm going to consider is the next term always less than or equal to the current term, but only for the positive aspect of it. So I'm really going to be like, well, I'm dealing with 1 over n because I don't want this alternating stuff, right? So again, nth term test, limit as n approaches infinity of 1 over n is equal to 0, passed, test 1, okay? Test 2, 1 over n plus 1, and then 1 over n, which one is consistently smaller? That one is, because the denominator is consistently larger, slightly, but larger. And so, yes, we just passed the alternating series test. So does this converge? Yes, it does. And so I find that fascinating, and I hope you do too. I find it fascinating that when I add 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus da 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 da, we get a divergent series that diverges. But if I do 1 over 1 minus 1 over 2 plus 1 over 3 minus 1 over 4, da 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 da, we get a convergent series. It converges. I use different grammatical words here. Conjugations? No, never mind. Anyway, I use the different words. But this one diverges and that one is convergent. And therefore, we can say that the alternating series converges conditionally. Oh, what does that mean? That means that the alternating series converged, but if I made everything positive, nope, diverged. All right? Let's jump in. Everything I just said is right here. We're going to have an alternating series. It could be either structure, however you want to put your exponent in, n plus 1, doesn't matter. You can start at 0 if you like. That's fine. It's just kind of a generic structure. A sub n is the positive aspect of it. So it takes away the toggle factor. That's the explicit formula where it's positive. This thing will converge, let's go to the second bullet, conditionally. If the alternating series converges, but the positive aspect diverges. That's what we just found with a harmonic series. Let's jump to the third bullet. If the alternating series fails, it's going to diverge if the alternating series fails. So if I did this and I got a no, I'd be like, no, just no. You diverge, you both diverge, you just diverge. That's it. It's going to converge absolutely. Here we go. Absolute convergence if the alternating series converges, if that's a yes, and its positive aspect also converges. So if that would have been a yes, this would converge absolutely. Doesn't matter what the signs are, it's going to converge. That's what absolute convergence means. Let's do an example. We're going to determine if each of these alternating series converges absolutely, converges conditionally, or if it diverges. And here's what we're really going to do. We are going to go ahead and do the alternating series test for this guy. So let's do the alternating series test. So it's really going to be a combination of things going on as you wave your hands back and forth. So purple over here. We're going to do the alternating series test, which is actually two tests. And that is when I say, well, let's do the nth term test for divergence. And we got to make sure that this thing equals 0. So ignoring the toggle factor, I'm saying if this thing was always positive, what would it be? Well, it'd be 3 over n factorial. So 3 over n factorial. I don't care about the fact that there's a negative that makes it go back and forth. All right, as n approaches infinity, we have 3 over enormous, and that is going to equal 0. We have passed that portion of the alternating series test. Second portion of the alternating series test is when I say positive aspect only, positive factors only, 3 over n plus 1 factorial, that's my next term. Is it consistently less than or equal to 3 over n plus, n factorial? Is this always less than? Well, yeah, it is. And we start at 0. Well, actually, if we plugged in a 0, we would have the same thing, because 0 here would make 1 factorial, 0 here would make 0 factorial, which is also 1. Either way, it's going to be less than or equal to, which is fine. We're allowed to do that. That's one of the situations that can happen in the alternating series test. Could be less than or equal to, and so check. Therefore, we're saving a lot of space here, but therefore I'm going to say that this series, the alternating series converges. Okay, good to know. Now, here's what I don't know. Will this thing converge if it was consistently positive? If that's true, then I'm going to add to this answer and I'm going to be like, yep, this thing's going to converge absolutely. Absolutely, like absolute value, kind of. So we have just passed the alternating series test. Let's move on. And we're going to just start all over with this series right here. And I'm going to check this series, but the positive aspect of it. Didn't you just do that? No, I did the alternating series test, which only requires the positive aspect of it. But now I'm just going to pure check this thing right here. I'm going to check that one using another bag of tricks that we have. Okay, is it geometric? Absolutely not. Is it p-series? Definitely not. What could I do? I'm going to check it with one of my favorites, limit comparison test. All right, limit comparison test. Here we go. That means that we're going to plug in the next term and divide it by the current term. So we're going to have the limit as, I should have switched colors. N approaches infinity of 3 over n plus 1 factorial over 3 over n factorial. All right, let's keep this train rolling. Limit as n approaches infinity of 3 over n plus 1 factorial. Let's not do that. N plus 1 factorial is really n plus 1 times n factorial. I like the limit comparison test. It's very practical. There we go. Oh my goodness, look at all that stuff that cancels out. Cancel, you're canceled. Mathematical cancel culture. There we go. 1 over n plus 1. This has no risk of being negative, but we'll put the bars anyway. All right, as n approaches infinity, this thing approaches 0, so 0, which is less than 1. All right, here's what that means. I'm glad you asked. This is going to be wonderful. What I have just found is that the alternating series test produced an alternating series that converges, but testing just the positive aspect produced a convergent series. So this converges as well. All right, final answer, I'm going to write it in red. Because the positive aspect converges and the alternating series converges, this thing has absolute convergence. It's going to converge whether it's positive, negative, whatever. So therefore, this thing right here, original problem, converges. Absolutely.